Thank you for watching. I'm Kotakino from JPSAT. Our presentation today is about Quasar. Before we get started, I would like to give a brief introduction about Quasar. Quasar is a very famous lab published on GitHub. Quasar has a lot of features required for a lab. The latest version works on Windows Vista and later versions. Quasar is using many attack operations. For example, an APT group called APT10 uses it in targeted attacks. It has also been reported by security vendors that Quasar is being used by many other APTs and criminal groups. So the goal of this presentation is to share the internal of the Quasar family and C2 hunting methods. Here's the agenda for today's presentation. First, we would like to talk about Quasar internals. Secondly, we would show rat belonging to Quasar family. Thirdly, we will introduce a campaign of targeted attacks by APTs using Quasar. Finally, we will share our method for hunting Quasar family C2. So let's move on to the first topic. Quasar client is coded in C#, therefore it can be decompiled using a tool such as DNSpy. The history of Quasar's version goes like this. Early on, it was called XRAT, followed by Quasar 1.0, 1.1, 1.2, 1.3, and the latest 1.4 was released in June of this year. Here's how Quasar communicates. The first one is XRAT, but this one contains the data size in the first 4 bytes, followed by 16 bytes of initial vector, and finally the data encrypted in AES-CBC mode. The encrypted data contains the 1-byte commands and the argument for the commands. Also, the AES key uses the MD5 hash value of the encryption key. Next is the Quasar 1.3, which is similar in structure to XRAT, but HMAC is used. In addition, the data is AES encrypted with an additional quick reset compilation process. Furthermore, the method of generating AES key has been changed from MD5 hash value to a method using PBKDF2. Finally, Quasar 1.4, the communication method has changed significantly from the previous version. The previous AES and quick reset are no longer used, and instead the data is serialized using protocol buffer, which is developed by Google. In addition, the communication is encrypted using TLS 1.2. The communication between the Quasar 1.3 client and the server goes like this. First, when Quasar client connects to the server requests authentication. The client then sends the authentication information to the server, and the server returns the response of authentication success. After the authentication is complete, data including commands are exchanged. Next, the communication between the Quasar 1.4 client and the server goes like this. Unlike Quasar 1.3, in 1.4, authentication will use TLS handshake. After the TLS handshake is completed, data including commands are exchanged. Next, let's take a look at the Quasar configuration. The first one is XRAT, but this one encrypts the configuration using AES and basic C4. The AES key uses the MD5 hash value of the key as well as the communication methods. The next one is Quasar, and like the communication method, HMAC is used here as well. The method of generating AES key also has been changed from MD5 hash value to a method using PBKDF2. Here's a list of configuration. In XRAT, there were ports and enabled UAC escalation configuration value, but after Quasar 1.0, they have been removed. Also, in Quasar 1.4, some new configuration value related to TLS communication, such as the server signature and the server certificate, have been added. Next, let's take a look at the Quasar commands. In Quasar, each command is defined with type of, and the command set is built using the command defined in type of. Decoded Quasar traffic will look like this. The command will be sent in 1-byte format, and depend on the command number, the corresponding command from the command set will be executed. Here is a list of commands. We can see that there are various commands. Next, we would like to introduce the Quasar family. There are so many variant RAT in Quasar. There are two main types of projects. A clone project, in which some features are added to the original Quasar, and refer project, in which the communication methods of Quasar are used. Here is a list of Quasar family. There are various RATs out there, but they all have configuration or communication methods that are consistent with Quasar. Let's take a look at some RATs of Quasar family. First, we would like to look at the Expectora. Expectora is using Brazil to see the credential of financial institutions. If we check the configuration, we can see that it's very similar to Quasar. On this slide, you could find the command of Expectora on the left hand and Quasar on the right hand. Most of the commands in Expectora match with Quasar. However, few unique commands have been added. Next is a RAT called Golden Edition. This one is created by using the original source code. If we look at the virus total detection result for Golden Edition, we can see that it's detected as Quasar. Also, we look at the version in the configuration. It has been claimed 1.4.0 since the original has released. Next, let's look at the China RAT. If you look at China RAT server, you'll see the icon and text have been changed compared to the GUI of the Quasar server. However, the main feature of China RAT are unchanged from Quasar. Next, let's take a look at the Venom RAT. Venom RAT is advertised on Hacking Forum and elsewhere, and is sold with a monthly subscription. When comparing the commands of Venom RAT and Quasar, most commands are common. However, there are some additional unique features, such as commands for installing RDP, VNC, seeding credential, and so on. Next, let's take a look at the async RAT. Async RAT is using the number of attacks, and we have seen cases of attacks. If you look at the top 10 threats reported weekly by any run, async RAT often ranks in the top 10. Async RAT has its open implementation, but it uses the same communication method as Quasar. Comparing the source code, you can see that the AES-256 sort value used in async RAT is exactly the same as the Quasar sort value. Also, the communication format is the same as in Quasar. Finally, let me introduce you BotRat. If you look up BotRat on Twitter and other sites, it has been reported that it's actually using attacks. BotRat is based on the compiled code since there is no source code, but we can see that the AES-256 sort value is used in BotRat. As in async RAT, it's an exact match to Quasar.
From this section, I would like to show two APT cases that use Quasar for their attacking campaign. In recent days, the APT actor uses open source RAT in general. This table shows the campaign that uses Quasar RAT for their attacks. From this table, you could find that Quasar is a well-known tool for APT actors. Most actors use the Quasar as is for their attacks. On the other hand, APT10 uses the custom version of Quasar. We will show the detail from the next slides. The first case we introduce is the case of APT33. In the case of APT33, they use Quasar as is for their campaign. Let's dive into the configuration they set for Quasar client. Here is the dump result of Quasar configuration. We dumped this configuration with our OSS tool BotConf scan. From this result, you could find that the default value is set in the tag field. And use the default log directory name, use its default install subdirectory, and install name. The only modified point is set the startup name into their original strings. Most attackers use the Quasar as is and use the default configuration. It means that it makes it easy to detect or hunt the payload. However, it also makes it challenging to determine the attribution only using configuration. Let's move on to the case of APT10. APT10 wraps their payload with multiple packer layers like Matryoshka. For their persistence, they register their payload as a service that executes a custom Quasar loader. Quasar loader reads the encrypted payload and unpacks it into the memory. This loader exports the external function and it decrypts the payload with AES-CBC mode. The file path shown on the slide is one of the samples the actor puts the encrypted payload. Customized APT10 Quasar has several unique features. There are 2 new configuration keys, different encryption algorithms, new commands, a new error log recorder, and a modified communication protocol. This figure shows the difference of configuration keys between APT10 Quasar and original Quasar. You can find that 2 keys are added. Download URL and proxy have been added to the configuration. We think the customization is supposed to use Quasar in the network with a proxy server such as an enterprise network. Here is the dump Quasar configuration that has been used in the APT10 campaign. The value of tag is the default. The value of subdirectory and startup key is the default. And value of log directory name is default. The only changed key is the value of reconnect delay from default. The default value is 3 seconds, but here they set 34 seconds for the reconnection delay. APT10 also uses a different encryption algorithm to decrypt the configuration payload. The original Quasar uses AES with CBC mode. However, in the APT10 Quasar, it uses CFB mode. Also, they have disabled several commands and added 2 new commands, do plugin response and do plugin. Do plugin command loads the plugin module, and do plugin response deletes the added plugin. We guess that they removed functions that cause antivirus detection, such as keylogger, and replaced it as a plugin to make it difficult to detect. They also added an error logging function. The path of the log file has hard-coded in the source code, so you can use this path as an IOC for your threat hunting. The communication protocol has been also modified. They have added a simple XOR encoding method to encode the communication payload. Also, they have changed the AES encryption mode from CBC to CFB. Okay, from this section, we will share the result of the active probing of Quasar C2 and the points to hunt malware family C2. You can hunt Quasar family C2 with VirusTotal, IoT search engines such as Shodan, Census, or FOFA, and whole internet scanning with an original scanner. Let's see how to hunt Quasar family C2. First, let's check the latest Quasar 1.4. To hunt the latest version of Quasar C2, you only need to check the TLS certification issuer. If the actor uses the default, connect TLS session and check the issuer name. Let's search the issuer strings Quasar server CA with the IoT search engines. You can find the C2 server with just few operations on IoT search engines. These IoT search engines make it easy to find C2 for us. Let's thanks to these search engines. Let's move on to the Quasar family C2. There are several kinds of Quasar family. However, the critical fact is that all of these family uses the same communication method. The first response packet has two characteristic features. First is the payload size. The payload has fixed size 0x44. The second is TCP payload header. This header is always be 0x40 with triple nodes. You could detect the C2 server with these two signatures. This diagram shows the initial TCP negotiation between the server and the client. If you want to scan C2 servers on the network, all you need to do is create a TCP session, read the first response payload, and check the size and the header. That's it. The first point to find the C2 server is finding out the characteristic features such as TLS cert name or payload size. These findings makes it easy to find the C2 server or detect RAT communications in your network. The second point is that find the characteristic communication in the lower layer like as TCP. If you use a higher layer, like an application layer, the cost to search C2 will increase and scaling out the scanning will be more difficult. Here is the result of Shodan search. In this case, we use the payload size and header for the search query. At this time, we were able to find 4 Quasar family servers that were running in Japan. And here is the result of our whole internet scan. 76 active Quasar servers were discovered in November 2020. The Quasar server number was not so large, but we suspect that several campaigns are still undergoing. We believe that this host data will be useful not only for researchers, but also for blue teams.
Finally, let me introduce the Quasar analysis tools we have released. We published 4 analysis tools on GitHub. After this slide, I will introduce these tools. First, MarketScan is a BotConf plugin that extracts configuration data of non-malware. This tool searches for malware such as Quasar in-memory image and dumps configuration data. If MarketScan finds a Quasar in memory, the configuration data will be dumped like this. Next, quasar.decode.py. This script can encode and decode Quasar communications. When running, It needs a decode key and only version 1.3 is supported. Next, Quasar panel.py. This script is dummy sheet that communications with Quasar client. For custom Quasars such as apt10, this script is useful because the default sheet panel does not support the custom Quasar client. Finally, Quasar client.py. This Python script client that communications with Quasar C2. When malware is connected to C2, it will be controlled of the host by the attacker, but this script can safely monitor the commands sent by the attacker. In this example, you can see that the attacker sent a "whoami" command. Let's talk about how to counterattack the Quasar C2 using the tools I just introduced. Quasar client.py has a count option. You can clone many Quasar clients by using the count option. You can collect many fake clients and stack C2 like this. In this example, you can the fake client operating system is Android, iOS, or macOS. Let's move on to demonstration. First, I would like to execute with the encryption key and count option. If the encryption key is correct, C2 will allow the fake client access like this. Quasar C2 does not check the information received from the client, so it can be spoofed or used for attacks. All of the tools introduced are published in JPSAT GitHub repository. Please check out our GitHub repository for more information. I would like to wrap up today's talks. First, we talk how the variant was created from the open source Quasar. Second, we introduced a detailed analysis results such as configuration data and communication protocol of Quasar and family. Finally, we talked how to find Quasar C2 with IoT search engine service or broadcast internet scan. This is the end of our presentation. We appreciate to give us an opportunity to talk at BotConf, and thank you for watching our talk.